So let's look at functions as graphs. They can be represented as graphs, and a lot of times we like looking at graphs because it's like a picture that can, tell us a lot of information. So here, notice that we have the input is the acres that are being mowed, and the output is the cost in dollars. Here's also a graph, but think about this and see if you think that this is a function or not. So this would not be a function because if I talked for a minute, then I might be paying 50 cents or I might be paying 85 cents. I'm not quite sure. If I talked for 2 minutes, they could charge me 50 cents, they might charge me 85 cents. So this would not represent a function because for the input of 1 minute, I have 2 different outputs. For the input of 2 minutes, I have 2 different outputs. And according to the definition of a function, for every input, I can only have 1 output. Functions are relations, but not all relations are functions. So let's talk about what a relation is. A relation from set A to set B is a correspondence between elements of set A and elements of set B. But unlike functions, we do not require that each element of A be paired with one and only one element of B. So any set of ordered pairs is a relationship. But note again that every function is a relation, but not every relation is a function. Let's go back to our example that we had earlier. The first one, that's not a function, but it is still a relation. The second, not a function, but still a relation. The last one is a function and a relation. And all of the ordered pairs we had, those are relations. All of them are relation, but only the ones that we identified earlier are functions. So let's look at an example. We have a high-end bike manufacturer incurs a daily fixed cost of $1,400 for overhead expenses, and the cost of a bike to be manufactured is $500 per bike. Find the cost of manufacturing X amount of bikes in a day. So to do this, we would say, okay, the cost of producing one bike is $500. We need to multiply that times X, and then our fixed costs for the day are $1,400. So our cost to produce X number of bikes is 500X plus 1,400. Now also we have a revenue equation, and we can look at this, and this is a function. The manufacturer sells the bikes for $700. Therefore, the revenue earned would be 700 times X. So we would write this in function notation. Now, we can represent the revenue as an ordered pair, that when we sell one bicycle, we're going to make $700. 2 bicycles, and that's our input, would be $1,400. If we sold 3 bicycles, we would have a revenue of $2,100, and if we sold 4 bicycles, we would have a revenue of $2,800. We can write the revenue as a table. We can make a little table there and show the number of bikes sold and the revenue earned. And we could also represent it as a graph. Now, profit is determined by subtracting the cost from the revenue. So here we have the profit is equal to the revenue minus the cost. So say we want to determine the profit of our bicycle business. We would have the revenue 700x minus the cost, so minus the quantity 500x plus 1400. So we would end up with a profit equation of 200x minus 1400.